Good morning. Today we will discuss more concepts of the tangents of circle. Okay. See, this is a circle. So whatever the tangents we want to draw, we want to draw the tangents from outside only. From inside we cannot draw the tangent. From inside we cannot draw the tangent. So what we can say here, no tangent can be drawn no tangent can be drawn to a circle. No tangent can be drawn to a circle from a point lying inside the circle. This is one point. Okay. Next point, there is one and only one tangent. See, there only one tangent. There on and only one tangent we can draw. There is one and only one tangent to a circle passing through a point lying on the circle. Okay. Another point, see, from an external point, from a point, how many tangents can we draw? See, this one, two, anything more we can draw? Can we draw anything more? No. How many tangents can we draw from an external point? Suppose this is external point, P is an external point which is outside of the circle. We can draw only two tangents to the circle. So what we can say? Exactly two tangents. Exactly two tangents can be drawn to a circle from an external point. Okay. Now from this external point, if we ask to find out the length of the tangents, we are drawing a tangent from this point. So up to which we have to take the measurement. This suppose PT is a tangent. We have drawn PT is a tangent. Okay, to the circle with center O. So here what is the point of contact? PM is the point of contact. So length of this tangent will be what? PM. Length of tangent, what will say? PM. Okay. And if it is N, this point is N. So this will be PN from P. And from T, if we take T, then TM. It is depend upon the point from where we are going to draw. The distance between that point and the point of contact, that is called the length of the tangent. Okay. Be careful here. PT is not the tangent. PT is tangent, but PT is not the length of the tangent. Here, if we take P is the external point, so PM will be the length of the tangent. And if we take T is the external point, TM will be the length of the tangent. Clear? Now, there is a characteristics between these two tangents. Both the tangents are equal. PM is equal to PN. From an external point, the length of the tangents are equal. Okay. the length of the tangent drawn from an external point to a circle are equal. The length of the tangents drawn from an external point to a circle are equal. This we can prove geometrically. These things we can prove geometrically. This is also known as theorem. Sometimes we are asked to prove in the exam. Okay. Prove that the length of the tangents from external points are equal. That we need to prove. So prove. How to prove this one? For this, we will draw a circle. This is a circle with center O. So this is a P. P is an external point. PA and PB. PA and PB are the tangents. And we have to prove that PA is equal to this PA is equal to PB. Okay. So here let we can say PA and PB, let PA and PB are two tangents to the circle with center O. To prove PA is equal to PB. Okay, this we need to prove. So to prove any theorem, first thing is we need to draw diagram. Four things we have to: diagram, then a statement. First is diagram, then a statement, then proof. Next is construction if it is needed, construction, and then proof. These four parts you have to keep in mind. First is diagram according to the question. Next is statement. Statement, this is the statement. This is the diagram, this is the statement. And next we will do the construction, we will write the construction, we will do the construction if needed. Okay. Sometimes to prove whatever the given, it may not be sufficient to prove that things. So we need extra construction to prove it. Next is proof. With the help of the axioms and postulates, we will prove it. Okay. For this, here nothing we are getting to prove these two sides that PA and PB equal. For this, we need to construct. What do we need to construct? We will join O with A, O with B. Then we will get a quadrilateral. From here also, you are not getting anything. So if we join O with P, so we are getting two triangles. One is OAP, another is OBP, two triangles. And if we can show that these two triangles are congruent, then by CPCT, corresponding part of congruent triangles, so we can say that these two sides are equal. So we need to show that these two triangles are congruent. So for congruent properties, how many criteria are there? Four criteria: SSS, then is SAS, another is ASA, another is RSS. Any of them is hold good with these two triangles, then we can say the triangles are congruent. Now see that what we can say. So first we will do the construction. Construction, what we have done? Join O with the points A, B and P. Okay, this we have done. This no need to write, so now proof. After doing the constructions, we are getting two triangles. In these two triangles, in triangle OAP and triangle OBP, this angle is right angle, this angle is right angle. Okay, angle OAP is equal to angle OBP. Both 90 degree, we can say both 90 degree. Okay. Next, see OP, this is the common side for both the triangles. This OP is equal to OP, common side. And another thing is OA is equal to OB. Why? Radii of the same circle, radii of the same circle, radii of the same circle. Now see, this is right angle, this is right angle, this is hypotenuse, opposite side of the right angle hypotenuse, this is side. So as per RHS, what we can say, the triangles, these two triangles are congruent. Therefore, triangle OAP congruence to triangle OBP as per RHS. So if the triangles are congruent, so corresponding parts are equal. So this is the corresponding AP is equal to PP, that is PA is equal to PB, we can say PA is equal to PB by CPCT. So proof finish, proved. So this is the proof of the theorem that tangents from an external points are equal. Okay. Here some points we can remember, note. What are the points we can remember here? See. If these two triangles are congruent, then corresponding angles are equal. Number 1, angle OPA, PA is equal to angle OPA, this angle is equal to angle OPB, this angle corresponding OPB, and that is these two are part of angle APB. So what we can say, half angle APB. Number 2, be careful, this will be used to solve the problem. Angle OAP is equal to angle OPB, and this is half of angle APB. Again, angle POA is equal to angle POB. This angle is equal to this angle, and these are the parts of the complete angle. So we can say half angle AOB. Okay. Number 3 notes. See, this is 90 degree, this is 90 degree. So opposite angles are 90 degree. Okay. Then 90 plus 180. This is nothing but what? APBO is nothing but a quadrilateral, and these two angles are 180 degrees. So sum of these two angles is what? 180 degree. Angle AOB plus angle APB is equal to what? 180 degree. Okay. Another thing what we can say, if the sum of opposite angles supplement to each other, then the quadrilateral is what? Cyclic quadrilateral. That APBO is cyclic quadrilateral. Okay. So these are the points we have to remember. Clear? And this will be help to solve the problems. So be careful. These points we need to remember. I hope all of you understand the theorem. If any doubt, let me know. I will try to clear your doubts. Okay. Thank you. Have a nice day.